Hello and welcome, future digital detectives and incident responders. Get ready to embark on an exhilarating journey into the world of digital forensics and incident response. I'm thrilled to have each and every one of you here ready to dive deep into the exciting realm where technology meets investigation. Over the next weeks, we'll unravel the mysteries of cyber incidents, explore the digital trails left behind, and master the techniques that bring digital miscreants to justice. From dissecting malware to analyzing network logs, analyzing processes, connections, you will be equipped with the skills to unveil the truth lurking in the digital shadows. But this course isn't just about theory. This first session will be conventionally theoretical, taking help of slides and explaining you about the basics of digital forensics and incident response, which is important for everybody to cover. You will not just learn the theory. It's about rolling up your sleeves and getting hands-on. You'll be tinkering with real-world scenarios and placing together the puzzle of each case. So get ready to channel your inner Sherlock Holmes as we navigate through the twists and turns of cyber incidents. Remember, the digital landscape is ever evolving, and your role as a future digital forensics expert is more crucial than ever. Let's embrace the challenges, conquer the unknown, and emerge as the next generation of DFIR heroes. So, without taking additional time, let's start with our first session. So, let's talk about digital forensics and incident response. What is digital forensics and incident response? Digital forensics and incident response are crucial components of modern cybersecurity. Let me just show you the first slide. I hope my slides are visible to you. So this digital forensics and incident response in front of you is they are the critical components of modern cybersecurity, playing a crucial role in identifying, investigating, and mitigating cyber threats and attacks. In today's digitally interconnected world, where organizations and individuals rely heavily on technology and the internet, everything is connected to the internet. There are many systems. Everybody is carrying a mobile phone, which is also connected with the internet. In this today's technology, the need to secure digital assets and respond effectively to incidents has become paramount. Digital forensics involves the process of collecting, preserving, analyzing, and presenting the digital evidence to understand how a cyber attack occurred, how this incident occurred, what information was compromised, and who might be responsible for that. It draws from various fields such as computer science, law enforcement, and information security to uncover evidence from various digital sources. What are these digital sources? These sources include the computers, the networks, the mobile devices, and the cloud services. This evidence can then be used for legal proceedings, internal investigations, and improving future cybersecurity strategies. Incident response, on the other hand, focuses on the immediate actions taken when a cybersecurity incident or breach is detected. It's a structured approach that aims to contain the incident, minimize the damage, and swiftly restore the normal operations. Incident response teams work to identify the scope and nature of the incident, assess the potential impact, and coordinate efforts to neutralize the threat. This often involves isolating affected systems, analyzing malware, identifying the attack's entry point, and preventing further unauthorized access. The importance of digital forensics and incident response lies in their ability to effectively manage and mitigate the aftermath of cyber incidents. Cyber attacks can lead to data breaches, financial losses, reputational damage, and legal consequences. By conducting thorough digital forensic investigations, experts can uncover the methods used by attackers and develop strategies to prevent similar incidents in the future. Likewise, a well-executed incident response plan helps organizations minimize downtime, recover lost data, and maintain stakeholder trust. For beginners, the beginners, understanding the fundamentals of digital forensics and incident response is essential as it provides a solid foundation for entering the world of cybersecurity. Learning about evidence preservation, data analysis techniques, legal considerations, and incident management prepares individuals to contribute effectively to cybersecurity teams and contribute to safeguarding the digital assets. Moving on to the digital forensics part and the incident response compromise. So there are three total parts, which I have categorized the digital forensics and incident response. The first part, digital forensics, is the process of collecting, analyzing, and preserving digital evidence to investigate the cyber incidents. It involves various specialized areas. The first one is the network forensics. The network, remember that this would be a theoretical introduction. This session would be a theoretical introduction of the whole course. In the coming videos, in the coming session, everything would be practical, everything would be hands-on, tools and techniques used in digital forensics and incident response. But those before starting with the practical session, every course video would have a theoretical introduction of what we are going to do, how we are going to do, and why is it important to do. Because theory is also important, getting the concept is also important, only the practical thing is not important. So we'll having a mix-up of both practical and theoretical sessions in the coming sessions, but this session is also important. The introduction thing is also important. Without knowing the field, without knowing what you are going to do, you cannot do that thing properly. So network forensics, A part of digital forensics involves examining the network traffic to uncover details about cyber attacks, data exfiltration, and unauthorized access. It helps reconstruct the sequence of events during an incident. The system forensics. The system forensics mostly includes the Windows and Linux, and the most of the environments they include the Windows. So this system forensics refers to investigating digital evidence on operating systems like Windows and Linux. This involves analyzing files, registry entries, and system logs to understand how an incident occurred and what actions were taken. Then comes the data breach forensics. Data breach forensics focuses on investigating data breaches, often involving sensitive information like personal data or financial records. It helps determining how the breach happened, what data was accessed, and who might be responsible to access that data for that attack. Then comes the dark web forensics. You may have, or everybody have heard about dark web. It involves monitoring and investigating activities on the dark web, which is a part of the internet and not indexed by the traditional search engines. It's used to track the illegal or illicit activities. Then comes the malware analysis. Malware analysis involves studying malicious software malware to understand its behavior, purpose, and potential impact. This is crucial for identifying and mitigating threats. Then comes the incident response. Incident response is the structured process of managing and mitigating cyber incidents. The first step involves the identification, in which it involves the detecting and confirming a potential security incident. This step includes initial analysis and assessment to determine the severity and nature of the incident. Then comes the containment and eradication. Once an incident is identified, is confirmed, the focus shifts to the containing its impact and eradicating the threat. This may involve isolating the affected systems, removing malware, and restoring the affected services. Then comes the root cause analysis, investigating the underlying cause of the incident to prevent it from happening again. This involves identifying vulnerabilities, misconfigurations, or human errors that allowed the incident to occur. Then comes the incident timeline analysis, which involves creating a timeline of events, helps understanding the sequence of actions during the incident. This aids to reconstruct that attack and assessing its impact. Then reporting part is effective. In the effective communication is very crucial. Reporting involves documenting and the incident, the actions taken, the impact, the recommendations for preventing similar incidents in the future. Then comes the compromise assessment, which is also a part of digital forensics and incident response. Compromise assessment evaluates whether a system or network has been compromised. Compromised means under attack. The first part of compromise assessment is pre-compromise assessment. It involves proactive measures to identify vulnerabilities and weaknesses in a system before a potential compromise. This helps prevent incidents. Then the post-compromise assessment conducted after an incident to determine the extent of the compromise, assess the damage, and identify any lingering threats. In summary, this whole slide we covered, it covers the key concepts of components of digital forensics and incident response and the compromise assessment. These processes are integral to effectively manage and respond to cyber incidents, preserving digital evidence, and enhancing cybersecurity practices. This was the slide covering, the first slide was covering the introduction, what is digital forensics and incident response, how that is important. We saw that everything is being shifted towards the technology, and nowadays cyber attacks are very common. Even a mobile device is a victim of cyber attack. So investigating these cyber attacks is important at the same time. And in the second slide, we studied about what kind of forensics we do. We do this network forensics, which includes the system forensics. The first part is the digital forensics, which includes the network forensics, system forensics, data breach forensics, dark web forensics, malware analysis. So you see there are many kinds of forensics and incident response. In the incident response, these are the steps. In the compromise assessment, these are the two types of compromise assessment. This is a diagram explanation of what is digital forensics. The first step is to identify what actually happened, which security solution reported that, or where was the incident identified. The second step is the preservation step. Again, if I'm speaking a bit fast in a fast pace, you can slow down at the pace from the video settings, or you can go back and revise the concept again, because including all the concept of digital forensics and incident response in the whole video is important. So the preservation step means the data which the system which is under attack is the data is evidence is preserved, so that it is not damaged, so that we can perform analysis at the back end from the evidence. Then the data is collected, then examined, then analysis is done, then the interpretation from the analysis is done, and then the documentation and evidence with presentation and the court is done, that this was the evidence of attack, this person entered into the system at this time, and this person was responsible for the attack. This is the whole root cause analysis. Then there is network forensics, which involves the collection and analysis of network traffic, including but not limited to access control list, unauthorized access, unauthorized configuration changes. If you are aware of cybersecurity, basic cybersecurity, you may know these terms, the communication patterns. The security solutions in the brackets ignore that. These are the security solutions which are providing some evidence in the forensics activity, but you can ignore that. Then the system forensics part. In the system forensic part, these details are highlighted for the Windows operating system only. So the analysis and acquisition of the following artifacts are done, and these artifacts, they all are explained in this course, whole course. How running processes are analyzed, how network practically we have carried out, we have used tool to analyze these all artifacts. And then comes the incident response. Incident response includes the preparation, detection and analysis, containment, eradication, recovery, post incident activity, and these kind of activities. So this was all from the introduction of digital forensics and incident response. We'll be covering the aspects of both digital forensics and incident response in the whole course. And the course is not limited to the theoretical part. Again, the course is all about practically carrying out the incident response, practically carrying out the digital forensics activities. We will be guiding you about the tools and techniques utilized in DFIR and how to use those tools and techniques. We'll be studying about these key artifacts. We'll be studying about the running processes, the network connections, the services, the scheduled tasks, the auto runs, what are they and how they're important. We'll be studying about all these things, the memory image analysis and disk image analysis. And besides the theoretical part in the first video, we'll be having all the practical part. And besides that practical part, in the start of every video, I'll be explaining you the importance of the tool and the artifact we are going to analyze, so that you have a complete idea of what we are doing, instead of just following my steps. So thank you so much. This was from the first session. See you in the next and practical session series. Thank you. Hello everyone, and welcome to today's demonstration lecture on the topic of understanding and creating disk images using FTK Imager. I'm Ashir, and I'm excited to guide you through the process of taking a disk image, specifically an E01 image using the FTK Imager tool. Before we dive into the practical demonstration, let's first understand what a disk image is and why it is important in the field of digital forensics. So a disk image is essentially a digital snapshot of the contents of a storage device. That device could be a hard drive, a USB, or anything, any hard device. It's a bit by bit copy. The disk image is a bit by bit copy of all the data stored on the device, including not only the files and folders, but the unallocated space and the hidden areas in the disk. Disk images play a crucial role in the digital forensics activity, and because they allow the investigators to preserve and analyze the state of a device at a specific point in time without altering the original data. You can understand from the example that if you are into a digital forensics case, if you are investigating a digital forensics case, if you are carrying out the forensics on a system, and you cannot work on the system itself because there is a high chance that the data on the system will get tampered, then you can probably take the disk image. Taking the disk image here in this case would mean that you are taking the system with you, but you have no fear that the data would be tampered because the system would be in its own state. It will be preserved, but you have a copy of the system. You can say a bit by bit copy. Everything which is inside the system would be in your disk image. Now that we understand the importance of disk images, let's move on to the practical demonstration using FTK Imager. I have this FTK Imager tool present on my desktop. Let me first install it. You can just download it from the Access Data official site. You have to just type FTK Imager on your browser, and it will prompt you for the download. Remember to download from the official site. So this is the installation procedure. Next, I accept the terms. Next, install. So it'll take a few seconds to get installed. It is installed. Now let's finish it. It will automatically open. So you can see that FTK Imager is now open in my screen. So you have to go in the file option and in the create disk image option, and from here you have to select the physical drive option. Opting for the physical drive image allows us to capture the entire contents of the storage device, including hidden and unallocated areas. This level of details is vital for the digital forensics activity as it ensures we capture every piece of the potential evidence. So, selecting the physical drive, click on the next button. And what is the physical drive? Yeah, this is the physical drive because it's a VM. If you have a USB plugged in, it will give you an option in the drop down menu, or the USB option would be here as well. You can take the snapshot of the USB as well, any hardware device. Click on the finish button, and now you will be prompted to input the image destination. Yes, this is important, you have to give the image destination. So yeah, now you have to select, after selecting the physical drive option, we are prompted to choose the image format. There are several formats available, including the raw, E01, you can see onto the screen. We'll go with the E01 format for this demonstration. The E01 format is a popular format in the forensics community due to its benefits. It allows for compression, encryption, segmentation in the imaging. Compression helps in saving storage space. Encryption ensures the image's security, and segmentation of the images allows large drives to be split into manageable segments for easier storage and analysis. So let's stick with the E01 format. Go ahead. And here are the details of the evidence. You can leave it if you want. You can fill it if you want. Click on the next button. Image destination folder. This is important. You have to give the destination where the image is to be stored. Let's give it the destination of desktop. I have the folder disk image on the desktop. Let's give it this for this destination. The file name, test. Test is the file name. The image format, fragment size. I think we should select here 0, because we don't want to segment the image. We want a single image, single E01 image. Compression, no, we don't want to compress it as well, so let's select 0. Use AD encryption, no, we don't want to encrypt the device, and then you have to select finish button. And now here you have to, if you want to check mark the verify thing, it will verify the image after it's been taken. It's a long procedure as well. And then just click on the start button. FTK imager needs 45080 MB to write in the next disk segment. Only this much space is available in this drive. So yes, this is important. When you're taking a disk image of the whole disk of the system, that disk image, the size of that disk image would be equal to the whole size of your disk. So basically, that's not possible to take the equal sized disk image and store it onto your disk. So in that case, you have to plug in any external device, hard drive, and connect it with the system. And the destination, you have to give the destination of the external hard drive, which should have enough space as of the disk space of the system. So in that case, in this case, we don't have a hard drive. We have not connected any hard drive. We don't have the space as well. So I already have taken a disk image. I already have the disk image on my desktop, not the disk image of the system, but sample disk image for your demonstration. We'll cancel this and I'll show you the disk image just in a few seconds. Okay, the disk image folder is here, and forget about this test one which we created just now. It's not the full image we created. So this is the test image. This would be the image. This is how the image would look like, E01 image. You cannot open it by double clicking it, or you cannot open it with any software, not any Microsoft software, built-in software. To parse this image, to view the contents of the whole disk, because the idea to take the disk image was to preserve the bit by bit copy of the system in order to analyze the system, conduct detailed forensics on the system. So how you are able to view this disk image, because you want this, you know that this is a bit by bit copy of the victim system, of the system you found on the victim side, and you want to perform root cause analysis, you want to conduct digital forensics. So how you will do that with this one single file? Basically, there are some tools available in the market which parse this file, and those tools will give you the contents of whole disk. In the coming sessions, I will try to make a video on the parsers, and we will analyze this disk image, and we'll see how those tools are helpful to analyze the external disk images, and how are they powerful. How are the ingest modules present in those tools are powerful enough to investigate any attack. those tools, remember that those tools will not display you the information of the disk in a way that is displayed onto your operating system. No, they'll have a lot more features. They'll have a lot more options available for you as a digital forensic investigator. You can see the deleted files at one option. You can see the images, all the images from the system at one option. You can see all the executables in the system at one option. You can see all the emails available in the system, even if it was it was entered during the submission of an application or software, or if it was in the email client of the system. No matter, all the emails from the system would be extracted by the tool from the disk image, and they'll show you in a separate option. Also, there are search options. You can apply the search in the whole system, in the whole disk. So it's a very powerful, there are very powerful tools available to analyze disk images. I'll show you in the coming session how the disk image is being parsed, and there you have it. We have covered the basics of disk images, their importance in digital forensics, and we have demonstrated the process of creating an E01 disk image using the FTK imager. By following these steps, investigators can preserve the integrity of the digital evidence while conducting the thorough analysis to uncover the insights. Thank you for joining me in this lecture. I hope you've gained a clear understanding of disk images and how to work with them using FTK imager. If you have any questions, feel free to add those in the comments. We'll see you in the next session. Thank you. Hello and welcome to another session in this series of digital forensics and incident response. Today we'll be talking about memory imaging. What is memory image? Memory imaging in the context of digital forensics refers to the process of capturing a snapshot of the volatile RAM, the volatile memory of a computer or device. What is a volatile memory? Volatile means that the contents of RAM would get lost if the system shuts down or it's powered off. But on the other hand, the ROM, read-only memory, for which the disk imaging is required, the contents are not lost even if the system is shut down or is powered off, because the contents are saved on the disk. Where the disk imaging of the ROM of the disk is important, on the same side, the memory imaging of the RAM is important. We'll see how it is important and what are the contents which are saved in the RAM. The snapshot, this memory image, contains the current state of the running processes. We have also seen in one of the videos in this series that how important is it to analyze the running processes, current running processes during a digital forensics and incident response activity. It also has contains the open files, the current state of the open files, the network connection. Again, in one of the videos we have explained in detail why and how network connection can be analyzed and why they're important in digital forensics or incident response. And it also contains other system information at a specific point of time. Unlike the traditional disk image forensics, which involves analyzing stored data on the hard drives or storage media, memory imaging focuses on the live state of a system. Memory imaging is crucial in digital forensics and incident response activity for several reasons. Firstly, the volatile memory holds a wealth of valuable information that may not be present on the disk, such as encryption keys, passwords, and active network connections. This real-time data can be critical in uncovering ongoing malicious activities or understanding the scope of a security incident. This is the real-time data on the disk. That was not the real-time data. That was the data which is saved on the disk, which we can get from the system as well. But when the system is shut down, it is powered off. We will lose the contents of the RAM. So before it gets powered off, it gets shut down, we have to take the memory image. We have to analyze the contents in the memory image. Secondly, the memory imaging can be used to detect and analyze advanced form of malware that operate in the memory and evade detection by traditional antivirus software. By examining memory contents, digital forensic experts can identify and dissect the malicious code, helping organizations to remove threats and prevent further compromises. Moreover, memory analysis provides insights into the sequence of events leading up to a security incident. By reconstructing the actions that are taken by an attacker in the memory, investigators can place together the timeline of an attack. We can establish the timeline of the attack, understanding the techniques employed, the tactics used, and identify the vulnerabilities that were exploited. This knowledge is invaluable for strengthening the organization's security posture and preventing the future breaches. In incident response scenarios, memory imaging allows for timely investigation and mitigation of security breaches. Since attackers often attempt to cover the tracks by deleting logs or altering disk-based data, volatile memory remains a reliable source of evidence in this scenario. Quick memory imaging during an ongoing incident can capture vital information before an attacker has a chance to erase the tracks. This is a tool. In my screen, you can see the tool dumpit.exe. So ignore the other files, the other two files. I'll let you know what are the other two files, what is the reason why I have placed these other two files over here. The tool is dumpit.exe, which you can see on my screen. This tool is used to take the memory image. There are several other tools, but we'll be using the simpler tool in this video. You just have to double click this tool, and once you double click, it is showing you the space address space size. It would occupy 5416 MB, but you have the free space size of 2969 MB. This is because I already captured the memory image, which is present over here. So let me delete this memory image, and then double click it again. Now you can see that there is some space which is freed, and now I have to press Y. Are you sure you want to continue? I pressed Y, and now it has started taking the memory image. I hope it would not take so long, because it's a VM and it is not running so many processes. It's a very short VM, short system. So summarizing this session today, let's give it some time, and let me explain you how important is memory imaging. Memory imaging plays a pivotal role in digital forensics and incident response by providing real-time insights into system activities, aiding in malware detection, reconstructing attack timelines, and preserving critical evidence that might otherwise be lost. Its ability to capture the volatile state of a system offers a unique perspective that complements traditional based forensic techniques, enhancing the effectiveness of cyber investigations and strengthening the organization's overall security strategy. Disk imaging uh, is an important part of digital forensics and incident response, and by taking the disk image, you basically save the contents of the whole disk into a single file, and you can basically take that image anywhere and analyze the disk contents. You don't need the system itself to analyze the activity. On the same side, memory image is also important. Where disk imaging is saving the contents of the disk, memory image is saving some other contents which are very important. The current running processes, they are not saved on the disk. You cannot find them by analyzing the disk image, but the current running processes are very important. As you can see in the coming videos in this course, that how current running processes are important during a digital forensic activity, how analyzing them is important, why it is important. And the current network connections, you can get the current network connections from the memory image. From the memory, if you have the access to the system, no problem. You cannot you should not take the memory image. If you have to do the analysis now, and your system will never get powered off, you can perform the whole part onto the system. But if you know that the system, there is a chance that system will shut down or power off in future, then you can probably take the memory image to be on a safer side. So taking the memory image, you can see the current running processes, the current running services, the current connections, current network connections, and many other things. The everything which is happening into the memory, you can analyze it into the memory image. You can see into the memory by analyzing the memory image. And there are some other activities which are done by the attacker. Malwares, they reside themselves into the memory instead of the disk to evade the detection, because anything on the disk, if it is malicious, the antivirus, the anti-malware, the firewalls, all the security solution, the endpoint protection, they will be able to detect the piece of malicious code. But if it is residing in the memory, they'll get evaded. There are 90% chance that they'll get evaded. So for that purpose, you have to analyze the memory as well. To analyze the memory, you have to take the memory image, and I think it is successful. Yes, there is a sign of success, and now you can see that there is a memory image in the .raw format. We saw that disk image was in .dd, .e01 format, but in the memory image is in .raw, .mem format. So analyzing this memory image is also important. And how to analyze this memory image? You cannot double click this file, as I talked about in the video of disk image, that we cannot double click the disk image to analyze the contents inside the disk image, but we need a tool. So for disk image, we used autopsy, but for the memory image, we cannot use autopsy tool. We have to use some other tools. So for analyzing the memory image, volatility is the best tool. It offers the command line utility as well, and the GUI as well. For the command line utility, we would have to move to the Kali Linux, deploy the volatility in the system, and then analyze the contents, and we'll see how to analyze the memory image contents. See you in the next video. Thank you. Hello everyone, and welcome back to our lecture series on digital forensics and incident response. In our previous session, we delved into the process of capturing a disk image using FTK Imager. Today, we are going to shift our focus on another essential tool in the realm of digital forensics and incident response, which is autopsy. We'll be exploring the importance of autopsy, and especially diving into its powerful feature, the ingest modules. So I have just double clicked on the Topsy tool, and you can find this tool on the official site of Basis Technology on any browser, and on any search engine, and you can just download it from the official site. And once you download it, there's a simple installing procedure of doing next, next, next. And once you download it, you'll load the disk image, and I'm going to explain you the whole process of loading the disk image in this session. Autopsy is an open source digital forensics tool which plays a crucial role in analyzing and investigating digital evidence, the disk image. It's designed to simplify the process of data analysis, making it easier for forensic investigators to examine the digital artifacts, the recovering of the deleted files, and the uncovering of relevant information from the disk image. All it's done by the autopsy tool. Autopsy's user-friendly interface and the comprehensive features make it a staple in the digital forensics toolkit. So let's now load the disk image which we took previously in the previous session, the E01 image. Now we have to load load the disk image into this tool, Autopsy. So you have to go to the new case and type the case name. Let's give it a case name of test, and click next. The case number, this is all optional information, you can leave that. Finish. And now it will be creating a new case for us. Once the image has been loaded, we can analyze the contents. In the next video, I'll be making a whole video on analyzing the ingest modules, the disk image, how to analyze. I'll be making a whole separate video for this purpose. This video is intended just to load the disk image, which is also a simple procedure, but yeah, we have to go through each and every step from taking disk image to analyzing disk image. There is an option ingest modules in disk image in the autopsy tool. Autopsy tool will be loading the ingest modules, and before going to the practical demonstration of how to check mark the ingest modules in order to load it in the tool, let me tell you about what are the ingest modules. I think it's done with the loading process. So let me first explain you practically how the ingest modules are loaded, and then I'll give you a bit theoretical concept of what are these ingest modules and why they are important. So yeah, add data source. We have to add the data source over here. Go with the first option, click on next, and now disk image or VM file. Yes, we have a VM file to get loaded into this autopsy tool. We have to give it the path. Will give the path of this test disk image E01 which we created in the previous session through FTK imager. Then click on the open button, and we'll go with the time zone. You can select the time zone according to the country you are in and click taking the disk image. This is important part. This disk image should be loaded in the time zone in which the system was. If the system was in this time zone, you have to choose this time zone. But if it was in a different time zone, because time is very important, if you are establishing the whole chain of events during a case, your time is important. Analyzing the time is very important. So if you somehow select a different time zone, then that would prove to be very difficult during the investigation. Go to the next option, and now these are the ingest modules. So at the heart of autopsy's capabilities, there are ingest modules. Ingest modules are a collection of pre-built tools that automate and streamline the process of data extraction and analysis. These modules aid in processing data from various sources, ensuring that investigators can efficiently sort through vast amounts of information without the need of the manual intervention. There are some types of ingest module which autopsy is equipped with. There are diverse range of ingest modules that cater to different types of digital evidence. Now let me explain you some of the ingest modules. One of them is the keyword search module. You can see over here. Here where the cursor is, I'm just check marking this module. This keyword search module enables investigators to search for specific keywords or phrases within the data, essential for identifying relevant information such as incriminating documents or communication. You can select the keywords to be enabled from here: the phone numbers, the IP addresses, the email addresses. You can select any of the keywords. The hash lookup module is there. Here is the hash lookup module. Hash lookup module compares file hashes against known hash databases to identify known malicious or illegal file. Again, this is very important in this module. It aids in quickly flagging files that may require further investigation. Then there is media playlist module, and this media playlist module identifies media files such as images, videos, and the data sets. When I'll be explaining you the analysis in the next video, there'll be some videos, there will be some audios, there will be some images you will be seeing in the next session when you will be analyzing the disk image. So those all things are they came from enabling the media ingest module. Then comes the email analysis module, the email parser module, which in other words, we say this as an email parser module. Email parser module parses the email messages and attachments to uncover communication patterns and potential evidence, assist in understanding the context of interactions among the involved parties. Then there's a timeline analysis module, and this timeline analysis module, it also proves handy during the digital forensic process. It creates a chronological timeline of user activity based on the extracted data, provides a comprehensive overview of user actions, aiding in the reconstructing or construction of the events. These ingest modules, they're very important. Ingest modules automate the manual task. The consistent application of modules ensures the investigation to follow established procedures, enhancing the credibility of the findings. They are comprehensive, they're specialized, and they're scalable. So you have to check mark these modules from here. We can see a bunch of modules. Recent activity module is here, hash lookup is here, file type identification is here, and picture analyzer, keyword search, email parser, and many other modules are here. So it's up to you to check mark the number of modules. The more the number of modules are, the larger that it will take time to load, because it will be extracting all these data, these ingest modules. Each ingest module will be extracting the relevant information from the disk image, and that would probably take a huge amount of time. So if you can wait, check mark all the which I recommend, check mark all the ingest modules, go with all the ingest modules, and then click on the next option. And now it will start to process data source and add into the local database. And this process would take a large amount of time depending on the resources you are having, depending on the size of disk image. And will be this whole session was all about loading the disk image. As I cannot show you the disk image being loaded in this session, this is a short session. When this completes, I'll come up with another session in the next session that this would be probably completed the loading process, and will be starting the analyzing process. So in conclusion, autopsies ingest modules serve as the backbone of efficient and effective digital forensic investigation. These modules empower the investigators to extract, analyze, and interpret digital evidence with precision and speed. By automating routine tasks and facilitating the examination of diverse data sources, autopsy significantly contributes to the success of modern digital forensics. Thank you for joining this session, and in our next session, we'll take a hands-on approach to demonstrate how to effectively utilize the autopsies ingest module. You can see the dashboard is over here, the loading is over here. It's 0% loaded right now. When it's done 100%, we'll come up with the dashboard in the next session. Thank you so much. Hello everyone, welcome back to our session on disk image analysis using autopsy. In our previous session, we learned how to load a disk image into autopsy. Now let's dive into the contents of autopsy's dashboard and explore the various ingest modules and how autopsy helps us extract valuable data from the image. As you can see on my screen, we have autopsy's dashboard in front of us. This dashboard is a central hub where we can manage and analyze the contents of our loaded disk image. Let's start by discussing the various sections and functionalities of this tool. First of all, let's discuss about the ingest modules. Before going deep diving into the ingest modules, let me tell you that the all information on the left pane, the file types, deleted files, the file size, operating system information, recent documents, recycle bin, web bookmarks, web downloads, encryption detected, encryption suspected, exif metadata, extension mismatch detected, keyword hits, user count suspected, and in the tags thing, other features. They all are the result of the ingest modules. One of the powerful features of autopsy is its ability to automatically process the extract the data using the ingest modules. Ingest modules, they are the plugins that help us extract specific types of data from the disk image. Autopsy offers a wide range of ingest modules for different purposes, such as extracting the file artifacts, the metadata of the file artifacts, the text content of the file artifacts, the images, and many more, which you can see in the left pane. So let's move to the demonstration. Let's take a closer look. As you can see here, we have a list of ingest modules on the left side of the dashboard. Each module focuses on a specific aspect of data extraction. For instance, we have modules for extracting emails, we have modules for extracting the images, the documents, the browser history, and even the geolocation data. So let me explore the operating system information. This is operating system information. The program name is Windows. The recent documents are here. The LNK files, the LNK files we already discussed in this course. What are LNK files? They're the shortcut files. When they are created whenever you open any file, any folder, any document, a shortcut file would be created on behalf of that file, document, or anything. So these shortcut files, they indicate the recent activity. So recent documents indicates that pictures, there's an LNK of pictures. That means this folder, pictures folder was open, this my loves folder was open, the system was open, and these are the recent documents, the downloads, documents, and desktop. The recycle bin artifacts are here. The web bookmarks are here. The web downloads, which is important, are here. This shows us the downloads, the backup date, data zone, funny thread. These are the things which are downloaded from the web. In the bottommost pane, you can see the text, the hex content, the text content in the form of strings, in the form of the index text, the source file metadata. The file metadata is here, the operating system account which performed this activity, the details of the account are here. And then coming on to the analysis results, the encryption detected. So these are the files which are encrypted. So it loading its ingest modules by using its one of the powerful ingest modules, it has detected the encryption. When you are analyzing a system, you have to go through every folder, every file to see if there is an encrypted file. There is no particular the search provided to you which can automatically detect encrypted files in your whole system. But this disk image, but taking disk image, analyzing it in autopsy, it'll automatically fetch the encrypted files from whole disk, whole system. It will show you the encrypted files. It will show you the encryption suspected status. This file is suspected to be encrypted. This exif metadata, this extension mismatch, these keywords, there are some keywords which there are some keywords on the basis of emails and anything else. So on the basis of these keywords, some hits are being performed, and going on to the email addresses, it has given us some email addresses, and you can see the list of email addresses over here. So if the system is suspected to have performed activity, some suspicious activity, email someone some critical data or shared information about a criminal activity through email, you can probably get that from here. And the OS accounts are here, the operating system accounts are here, the SIDs are here, the host name are here, the login name is here. There's only one account over here. The deleted files in this option, all files, there were 0 deleted files. The file types, again, you can have the files using the file types one. There are 1556 images in this disk, so you can load these images. Again, if you want to see the content in the files, if it is an image, you can see, you want to see the image. If it is a document, you want to see the contents, you just have to click the file and it will give you the contents over here. So let me just expand it so you can see the picture. The pictures over here, if you want to, you can see the location picture. So something happened in this whole system, somebody was trying to do something. If you have the correct timestamps, just go and follow the activity in that timestamp, follow each and every activity. The image is downloaded, the web, the things which are done on the web browser, the web downloads, the emails done on in that time frame, and everything. Then you can probably establish a complete chain of the incident. So if you want to download a specific thing, if you want to download from here, just right click on the file and extract file. And here I want to extract this file to the desktop, and let's see if it is extracted. Yes, this is the image over here. This is successfully extracted. So if you want to extract any image using autopsy, you just have to right click and extract the file. Sometimes for the registry files, we have to extract in order to parse them, because there are some files which need to be parsed in order to view. For instance, the log files, we need to parse the log files. So we have to extract the log files from by right clicking the folder. The registry files, again, and if there are any executable, and we may have to analyze the executables if they are suspicious or not, so we need to right click the executable and extract. So videos, there are 0 videos. Audios, there are 6 audios. You can extract these audios as well by right clicking and extracting. So Autopsy, when we select any ingest module, Autopsy actually goes through the disk image and identifies the relevant data based on the module's criteria. For instance, if we select the, we saw in the previous video, we were check marking the ingest module. So if we check mark the encryption ingest module, Autopsy goes through the disk image and identifies the relevant data based on the encryption criteria. It then extracts the data and present it to us in a structured manner, making it easy to review and analyze, which we can see. So about the email ingest module, so let's consider the email ingest module as an example. When we run this module, Autopsy scans the disk image for email related artifacts such as email messages and attachments. It then presents us with a list of extracted emails, including the sender and recipient information, timestamps, subjects, and attachments, which you can see over here. If we click on a particular email, for instance, let's click on this email. It will give us the information, whole information in the txt format. Here is the information. It will take some time to load. Now you might be wondering, why is this data extraction process important for us? Well, it's crucial for digital forensic investigation. By extracting and analyzing specific types of data, we can uncover crucial evidence, establish timelines, and gain insights into the activities that occurred onto the system. You can see the contents over here. So you can analyze the emails for the contents. What was the email? Who was the sender? Who was the receiver? What was the what were the contents of the email? What was the information being shared in the email account? User content suspected. What is this welcome scan.jpg? So there are a lot of things. If you want to scroll down to the folders in the way you do in the system, you just have to go onto the data sources, the image, then the image, and the folders are here. The hierarchy is here. You can go on and extract the evidences by moving on to the folders one by one. The fishy folder, um, this zip file is over here. You will never find my fish. This seems suspicious. This, if that's related to the case, you can extract that and see what's inside here. And if that zip file is encrypted, there are some decrypting tools available to decrypt the zip files. You can decrypt the zip files with the tools. Here are the users, and these are the two users. If we go to this user, you can see the desktop downloads and everything about this user. So moving on to app data, and if you remember, we have studied about LNK files, which are over Microsoft, Windows, and recent. So LNK files are here. So you can extract, basically the purpose is to show you how you can extract evidence from the disk image, how you can parse the disk image, because in one of the previous sessions when we learned how to take the disk image, we took a disk image in E01 format, which was a single file. We didn't know how to extract evidence from that single file. So these are the tools. Autopsy is one of the tools. There are many more tools available in the market. So you can extract, you can parse the evidence in a very nicer way in by using these tools. Autopsy is one of them. So in conclusion, Autopsy's dashboard and ingest modules play a pivotal role in helping us extract, organize, and analyze data from a disk image. These features enhance our ability to conduct thorough investigations and make informed decisions based on the evidence we uncover. That wraps our explanation for Autopsy's dashboard and Autopsy's tool today, the ingest modules and the data extraction process. In our next session, we'll dive deeper into how to take the memory image. Memory image is also important during incident investigation, and we'll see what is memory image and how it's important, how it's different from disk image. See you in the next session. Thank you.